Hello guys, hi. So this is the continuation of project management series, and this is the lecture 48 or maybe 50, whatever. So this is about the calculating probability. Remember that I told you the z value. So the z is equal to x minus mu divided by standard deviation. Z is this one. This is the area on this line. You calculate the z, the area under the curve, how much percentage. So x is variable. You see this, there is a x. So x is variable. You can pick any x. Like you can pick between if this is 60 days or earlier finish, and you pick 61 here. So you can calculate that how much area will be between 61%. 61 days when you are completing earliest your project in 61 days. So you can calculate this using the z x minus mu divided by sigma, where x is variable, mu is the mean, and sigma is the standard deviation. Already I told you one standard deviation we calculated like on either side. So from 60 plus 3 is 63 plus 66 3 6 69. So this is a very good representation of normal distribution. And here I have calculated the z value for you guys. So let's start. So let's say x is equal to we want to find out that we want to calculate earliest our project from their completion days of 70 days. Let's say it's 65 days. So this is 60 days earliest finish, and our one standard deviation is 3, so 63. So our point is between 63 and 66. So it's approximately it's here 65. So you draw a line, and the whole area you're gonna find it while using the z equation. So and this you want to complete your project before your completion date of 70 days, which they before 70 days. So here how we can do. So total area under the curve is 1. This is statistic. I have a very good video about statistic. So the area under the curve is 1. So our expected total expected time or earliest finish of the project is 60 days, which is the mean of the 5 or 6 activities which I have done on critical path. So this is our mean, and this is also our earliest finish. Latest finish we want before our latest finish 70 days, we want to complete the project 65 days. So here is the z. So when you calculating z, so z is equal to x minus mu divided by standard deviation. So here in the distribution we have 65 days, that's our variable x, and minus 60 is our mean, our earliest finish, or let's say 65 is our latest finish, and divided by 3 is our standard deviation. So we got 5 by 3, so we got 1.666. So what you do, you go and there is a table online z table for normal distribution, and go to z table, or in the book if there is some statistic book z table, go to z table and then go to 1.6 down, starting from 1 all the way to the number there, whatever the last number, but go to 1.6 down, and then from 1.6 you go to 1.6, you find the line, and then from there you go right all the way to 0.06, because here is 1.66. so 1.6 we got here in the table on when we go down in the line. serial number, so you got 1.6, and here what we left 0.06. So and from there you go to the right side, so you got the number under the 0.06 at the top and the side 1.6, you got 0.45154. so that's the number you got there. Okay, but here is trick. So you got the z value or the area under the curve between 65 days and minus 60 days. Here you got this area, which I make it yellow, but we have the whole 66 days, the 65 days, so from here to here, and we know that the mean or our latest earliest finish 60 days divide the mean, the curve half, like 50% of the area is on this side and 50% on this side. But according to statistics, so 0.5 is on this side and 0.5 is on this side. So when you be calculating 65 days, so from 51 to 60 days to the mean, we know it's 0.5, and this what we calculated, this one 0.45154. so here the total area is equal to 0.5 plus 0.451 is equal to 0.95, and we know in maths that 0.95 mean 95%. What you do, you multiply it by 100, so 0.95 multiplied by 100, so you got 95%. Or it's also like 0.95 mean, if you know the maths or statistic best and you have a very good understanding, so 0.95 mean 99%. Yeah, simple. 0.5 mean 50%, 0.4 mean 40%. So it's actually dividing the 1, and 0.1, 0.2, 0.3, 0.4 are dividing 100 into 10 and 20 and 30 like this, so it's gonna be very lengthy. So we got 95%. So what is our what we got here? So the probability of completing project before 65 days is 95%, guys. You have 95% of chances that you can complete the project before 65 days. 95%, almost done, you know. It will be the end. So this is what we have covered today, how to calculate the z value, zx minus mu. X is variable, mu is mean, and sigma is standard deviation. Sigma is the under root of the variance, which is a common equation I give you, and this is the normal distribution what I have done for the project. Our earliest finish is 60 days and our latest finish is 70 days. So then we decide to complete our project before 70 days, let's 65. So I calculated the area using this formula, z is equal to latest finish minus earliest finish divided by standard deviation. So 65 minus 60 by 3, we got this. And then the most important thing, in the table we went down to 1.6, and from there we went right and see upward 0.06 and 0.45 we calculated, and then we add both. We know the area between under the curve is 1, so 0.5% is on the left of the 60% and plus what we have calculated. So what we got, 0.95 is 95%. So the probability of completing project before 65 days is 95%. So thank you guys, and I hope you got the idea, and have a nice day. Bye.